are Team 2332, and this is the project that we've been working on thus far in this semester. Go to the next slide, please. All right, so the problem that we've been addressing is that there have been an increasing amount of natural disasters that have been occurring throughout the United States and throughout the world in general. And so as a result, there have been a lot of efforts by certain organizations or like federal organizations to respond to these natural disasters that have been happening. At the beginning, they've mostly been focusing on short-term to medium-term responses, so like emergency response and things like that, but they transitioned more into a long-term scope kind of thing where they've been focusing not so much on responding to the disasters, but actually mitigating the effects of the disasters that they have on these communities. If you can go to the next slide, please. And so as a result, there have been a lot more projects for this disaster mitigation and recovery. And so as a result, there have been an exponential increase in the amount of funding and budgets for these projects. However, with the increasing amount of projects, there's also there has been poor fund management, and so we need to create something that can essentially distinguish which projects to fund and how much to provide to these so that they can give a higher impact and so that we can reduce the amount of repeated spending that goes on with this. So if you can go to the next slide, please. And so we've been working alongside iParametrics for this. They're essentially a company headquartered in Atlanta, and the services they provide have to do with emergency management, security and risk assessment, and resilience consulting. And for our project, we're mainly focusing on the service of project and cost management that they provide. And so if you can go to the next slide. And so our project comprises of something that's heavy with data visualization, analytics, and data science. And so what we came up with is something called the Community Willingness and Capability Score, or CWCS. And essentially, this is a metric that we can use to distinguish certain projects that should be funded. And this would be able to, like I mentioned earlier, it would prevent wasted funds, so that we can efficiently use the money to create higher impact projects. And so some factors that we need to consider for this in calculating the CWCS for these communities are things like disaster frequency and magnitude, population vulnerability, and access to assets, and many more. And so our project comes in the form of a web app where the user can view a community mitigation success profile and its CWCS, and kind of like a breakdown and the factors that we took in consideration into calculating that score. And in terms of competitors and things that separate us from others, currently there aren't many other known services that do something like this. And this would also be something that's done mostly in-house with iParametrics. And so if you could move on to the next slide. Yeah, so this also ties into who would actually be using our project. And the main users of our projects are just the iParametrics employees themselves. And so we need to make sure that the scores, the breakdown, and the data that we used is displayed neatly for them to look at and view and understand how and why we were able to come up with these scores. And we need to focus on making a system so that only iParametric employees can view the data, because it can be considered rather sensitive. And another user, although it's indirect, would be FEMA, which is the federal agency that deals with emergency mitigation and things of that sort. And so some things that we also expect of the user is that we don't expect the user to have too much technical expertise, as iParametrics mostly outsources to third parties for their technical work, which would be us in that case. And so we need to make sure that, like I mentioned earlier, that this data can just be displayed for them to view, as this will be used as our application would be used in mostly a case-by-case basis.
So some of the main features, kind of from a bare bones perspective of our application, would be the ability to view CWCS scores and profile scores for communities across the country. And so kind of the main way that this is going to be done is users will be able to search for the community that they're looking for, and then the CWCS as well as the risk factors and associated data with the CWCS will be displayed on that kind of page with the community, and this CWCS will be calculated using an ML algorithm. Aside from that, another main feature is the ability to input data to generate CWCS and profiles for communities. I'm sure, as we all know, data changes very frequently, and so there exists a need for users of this application to be able to input data as kind of factors change in community, whether it be kind of in a positive way or negative way. And kind of the main way that we visualize this working is that data will be fed into the back end and scores and profiles will update appropriately. And I guess the last main feature that we have is the ability to export and visualize data. So ultimately, this application is used as kind of a data source and data visualization tool for iParametrics employees to pitch mitigation efforts. And so the ability to export and visualize data allows iParametrics employees to take the data and kind of present that to outside parties in determining, where funds are going to go for mitigation research, for mitigation. And so some constraints that we need to take into account is the fact that data privacy is a big issue. So this is primarily because the data is highly sensitive to iParametrics as a whole, as iParametrics are a disaster kind of relief focused organization. Unauthorized users must not be able to access the application or the data, as this will allow them to kind of impede on iParametrics business. Aside from that, another kind of constraint is the fact that it is incredibly difficult to quantify a willingness score just because there are so many different factors that interact in so many different ways. And so in order to kind of overcome this constraint, what we need to do is come up with an algorithm that fits to kind of the best that it can. And so in terms of our actual tech stack in implementing this application, we're going to have both a front end and a back end. The front end is essentially just a front end. It's just going to kind of display all the data that it needs to. But on the back end, we're going to have a database built using SQL Azure, as well as a Python script or Python ML script that'll be able to use the data located in the database to kind of come up with the CWCS scores. And so for our front end, we've kind of chosen to use React primarily because members of our team have experience with it, but also aside from that, React is pretty widely used on the front end. In terms of the back end, we use Python because ML is typically done in Python, and so there are a lot of libraries that are helpful for that. And then lastly, kind of the reason we're using Azure is because iParametrics themselves are familiar with the platform, and so they figured that it would be the best way for us to kind of proceed.
So in terms of the progress we have made so far, we have built a working prototype, which is a React app that allows a user to search for the CWCS Community Willingness and Capability Score of a specific region and find the top few factors that contribute to the score. We have the functionality to parse through a large data set of cities with different statistics and create JSON objects for the app to then render and display on the web page. We also got a better understanding of the data schema we're working with, what is expected of us, and now we have a clear-cut roadmap ahead of us of how our product will evolve. Next slide. So what did we learn? We learned how to develop an app from the ground up, what goes into planning it, the various aspects and functionalities, as well as how to work with the client and how to operate in sprints. We have incorporated all our clients' needs for now. We also did a lot of research into what factors constitute the amount of funding a region gets for disaster management, which included reading a lot of research papers. And finally, we learned how to do user research, how to properly address the needs of the customer, and work on the Nielsen's 10 principles to improve user experience. Next slide. So here is a working prototype where we first create an account using the username user and password admin. Once the user creates the account, we log in with those credentials. Once the user logs in, they're shown a list of communities with their CWCS and a search bar to be able to search. Here we search for Fulton County, which once we click on it, we see the score and the 3 factors that contribute to the CWCS. Next slide.
So we have a pretty clear-cut roadmap for Spring 23. Our number one priority will be to build a fully functional app that not only authorizes users to log in, but also use the app, use all aspects of the app, and really work on high level. We also want to integrate the database with our app. We're currently reading data through text files, which is not a sustainable solution as the amounts of data increases. So we plan to read the data from a database and build that next semester. We also have to develop a proper algorithm that generates the CWCS score. That's really the main aspect of our app. So we're going to have to spend a lot of time, finalizing the algorithm that generates that score. We also want to improve the user experience and create a much more visually appealing experience for the user and make it really easy for them to navigate through the app. And we'll also work with the client to improve the app and add any more features if necessary. We'll work with them on demand basis. So that's our plan for Spring 23.